This is number 4 from the kinetics chapter in OpenStax chemistry. We've got a chemical reaction here, and we've got time information and we've got concentration information for that exact same chemical. When doing these types of problems, it's important to be able to write the rate in terms of this concentration. Now, because it's a reactant, we use a negative sign, and this is going to be the change in concentration of C4H6 divided by change in time. But what I want to highlight here is the fact that there's a 2 here, so we put a 2 under there, so we can actually calculate the rate of reaction. Whenever you have a triangle, that means delta, that means final minus initial. So if we're dealing with the first set of times here, we want to take the negative sign, and we want to have the final concentration minus the initial concentration. The final concentration is going to be at the 1600 seconds. That's 5.04 times 10 to the minus 3. And the initial concentration is going to be 1.00 times 10 to the minus 2. Now you might be wondering, why do we have this negative sign here? It's because when you do final minus initial, you're going to get a negative number, and so that's why this negative sign is here. It's so that the rate is always a positive quantity. We want to divide by 2 times the change in time, so that's final time minus initial time. I forgot to put my units of molarity in here. And so let's go ahead and calculate that out. So up on top I get minus 4.96 times 10 to the minus 3. And on the bottom I get 3200 seconds. So these negative signs help us turn this quantity into a positive quantity. And for the final answer here, I get 1.55 times 10 to the minus 6. And the units here are molarity per second. Okay. Hit the pause and try to do the other problem and see what you get. I'm going to go ahead and work it out here too. So once again, we start off with the rate. It's going to be equal to minus the change in concentration of C4H6 divided by 2 times the change in the time, and that's final minus initial. Since we're dealing with 3200 and 1600 data points, we do the final concentration, 3.37 times 10 to the minus 3 molar. Subtract the initial concentration for this time interval. Okay. And divide that by twice the time. So again, it's 3200 seconds is the final time, minus 1600 seconds is the initial time. And so let's punch this in on a calculator. Okay, so I've got a minus sign there, and then I get minus 1.67 times 10 to the minus 3 molarity, and we want to divide that by 3200. Okay, so 3200 minus 1600 is 1600, and we multiply that by 2, So that's how I'm getting the 3200 down here. Okay, these two minus signs take care of the negatives in this problem. And so 1.67 times 10 to the minus 3 divided by 3200 is equal to 5.22 times 10 to the minus 7. And the units there are molarity per second. These two are the answers or the rates for those time intervals. What you should notice is that the reaction rate is steadily decreasing. Okay. For the first interval, the rate was pretty fast, 10 to the minus 6. For the second interval, the rate went down. It's now 10 to the minus 7th. And that's common. That's normal. Thanks for watching.